Okay, so I want to introduce the quotient rule, and I want to explain that this one right here, first of all, we actually don't have to use the quotient rule for. In fact, I'm going to show you how we could do this one using just normal rules by simplifying first, then show you how we could find the same derivative using the product rule. And then we'll use that process actually to derive what the quotient rule actually is. Okay, and the reason why I start with this one is so you can see how they kind of work together, and then in the future you'll see how the quotient rule is really helpful because it. There are times when you can't simplify, like we can here, and there will be times when, you could always use the product rule, but you just end up doing the same stuff anyways. Okay. So first of all, the first method that we could use is simplifying. Okay. Because our denominator is a monomial, I could split this up into two separate fractions. Okay? I could make this 2x over x squared minus 3 over x squared. Okay? And then I could rewrite this as 2 over x minus 3 over x squared. Okay? And I'll call this y to begin with. So notice here, I'm just working with the original function. And then, in order to find the derivative, I could rewrite this as 2x to the negative 1 minus 3x to the negative 2. Okay, now we're just dealing with derivative of x to the n. Okay, so we bring that out. What's the derivative of 2x to the negative 1?
Negative 2x, negative 2.
Good, negative 2x to the negative 2. And then what's the derivative of minus 3x to the negative 2?
9x to the negative 4.
6x to the negative 3.
6x. Negative 2 times negative 3 would be positive 6. And then we subtract 1. Okay, so it would be negative third. Okay? Now, just to show you, using our other methods, we won't normally end up quite here. It'll actually look a little bit differently. Let me show you what it will end up looking like. We could actually factor out an x. I could actually factor out a minus 2x to the negative 2 power, and that'll be a 1 times a negative 3x to the negative first power. Okay? That's one thing I could do. Another thing I could do is write this as fractions. Negative 2 over x squared plus 6 over x cubed. And I could actually get a common denominator and put those together. Okay? I could make it a negative 2x over an x cubed. Okay? A negative 2x plus 6 over x cubed. By getting a common denominator and adding those together. So there are a couple of different ways this could look. Alright, but we could stop here. So what would this look like if I did, instead of reducing first, how could we use the product rule? Well, I would have to rewrite this a bit. Okay? Because obviously this is a fraction, but how could I rewrite y using the product rule?
X to the x to the negative second times 2x minus 3.
Very good. X to the negative second times 2x minus 3. Now, I could call this u and this v, and dy dx is u prime v plus uv prime. There's our product rule that we've been using. And over here, u prime, what's the derivative of x to the negative 2? Good, negative 2x to the negative third. And what's the derivative of v? Just 2. Okay? So now when I'm going to do our dy dx, u prime, negative 2x to the negative third, times v, 2x minus 3, plus u, x to the negative 2 power, v prime, so just times 2, I can now simplify, right? So here we have a negative 2 x to the negative third times 2x. That's going to be a negative 4x to the negative 2 power. Okay? Negative 3 plus 1 would be negative 2. So it's a negative 2 power. And then I multiply, there's a plus 6 x to the negative third. And then this is just a plus 2x to the negative 2. So I have some like terms I can combine here. And I have negative 2x to the negative 2 plus 6x to the negative third, which is the same thing that we had right over here. Okay? Now, you guys know any division problem can be written as a multiplication problem, just like this. Okay? So let's actually see how we could derive a quotient rule, okay, and try to come up with an actual rule that will work anytime we have a fraction, okay? So, let's think about this. Okay. Deriving the quotient rule. Right. So first of all, let's let y equal u of x divided by v of x. Okay? And what I'm going to do then is I'm going to say that u of x, this equals the same thing as v of x to the negative 1. Okay. So here's my quotient. I'm rewriting it as multiplication. Okay? Now, if I'm going to use the product rule, here I'm going to need to use the chain rule, right? So let's look at how this will work, okay? First of all, we're going to call this, if this is u, then obviously we need to do u prime, okay? The derivative here with respect to x is going to be, using our chain rule, negative 1 times v of x to the negative 2, okay? Something to the negative 1 power, the derivative is negative 1 times that to the negative 2 power, right? Okay? Times, this inner function is v, right? So that's going to be v prime. Okay? Does everyone follow so far? Alright, so let's find dy dx using our product rule. First of all, we have u prime times v. Well, in this case, our v for the product rule is actually this entire thing to the negative 1. Okay? So this is going to be v, I'll just write it this way, v to the negative 1 power. Okay? U times v to the negative 1. Okay? So we have u prime v, or u prime times that second factor, plus u, the original function is u, times the derivative of this second factor. Well, that's what we just found over here. So that's going to be a negative 1 times v to the negative 2 times v prime. Okay? Everyone with me so far? Now, one thing that this is going to do, having this as a quotient, I'm always going to have this negative 1 power. So notice what it's going to do. I'm always going to have this negative 1 here, which is going to make this, instead of addition, it's going to make it subtraction. Okay? So we have u prime, and I'm going to write this as over v, you'll see why in a minute, minus, there's my negative 1, and then I have uv prime over v to the negative 2, or I'm sorry, v squared. It's over v squared. Does everyone see how we got from here to here? I translated the negative exponents into fractions. I pulled the negative out in front. Okay? Now let's get a common denominator. My common denominator will be v squared. So I need to multiply this by a v times a v, or over a v. Okay? And now look at what I have. U prime v minus uv prime all over v squared. So you can see here there's a similarity between the product rule and the quotient rule. In fact, the numerator is almost the product rule. It's just the product rule with subtraction. Okay? U prime v minus uv prime. And then the whole thing is divided by a v squared. Okay? So, there's our rule. Okay? There's the actual statement of the rule. dy dx is u prime v over minus uv prime all over v squared. So, let's go back and redo this problem. 2x minus 3 over x squared, and, okay? So if 2x minus 3 over x squared we'll identify our numerator is always u, okay? In the past, it hasn't mattered if we called one u and the other v, because division is not commutative. It does matter. The numerator is always u. The denominator is always v, okay? So, u prime equals what?
2.
2. V prime is
X squared. 2x.
Well, v is x squared,
yeah,
so v
right,
prime is,
2, yeah.
yeah, there you go, 2x. And now we can plug it into our formula. Okay? dy dx equals u prime, 2, times v, x squared, which I don't need the parentheses, so 2 times x squared, minus u, 2x minus 3, I do need parentheses there, times a v prime, 2x, all over v squared. This is the part that people will mess up. Okay? Because they'll forget to square it, especially if it's something like this where it's already an x squared. It's an x squared squared. Okay? So we should have x to the 4th in our denominator. So now, check out what we've got, okay? We have here a 2x squared minus 4x squared plus a 6x, all in the numerator, over an x to the 4th. That gives us a minus 2x squared plus 6x all over an x to the 4th, which we can just stop right there, okay? You do not need to continue to simplify. If we did, however, noticing there's a common factor of a 2x in our numerator, okay? Well, I don't need a 2x, I just need the x.
I got minus 6x.
Well, a negative times the negative 3 would be a plus 6x. I can cancel out an x here, and I would have a minus 2x plus 6 all over x cubed. Okay? And we can stop there. Okay, you should actually cancel out the x. What you don't need to do is go any further. We could split this into two fractions, and we'd get a negative 2 over x squared plus a 6 over x cubed, and the only reason I'll write that down is because that is exactly what we got back here. Negative 2 over x squared plus 6 over x cubed.
I did it a different way. I split it first. I just took the whole x squared, so after I canceled out the x squared at the top, I took the remaining x squared at the bottom and just multiplied it by the whole thing.
Yeah, you
Just
could.
did it that way.
You could. Oh, are you talking about up here?
I'm talking about when you cross out like the x. Yeah, when you cross out the x squared at the top and you're left with x squared at the bottom.
Mm-hmm.
I took x to the negative second power and just multiplied it by the negative 2x plus 6. You see what I mean? And then it turned out to the same answer.
Oh, okay. So you did this. You canceled out.
The x squared at the top.
Okay, so you made it negative 2 over x squared right here.
I had negative 2x, or no, negative 2 plus 6x over x squared. And then I took the whole numerator and multiplied it by x to the negative second. Was that wrong? Okay. Because it's technically 1 over, you know what I mean?
Well, you can't cancel the x squared out because this only has an x to the first. This would be like an x to the negative 1. If you canceled out 2 x's here, you have to cancel 2 x's out of here, and that would make an x to the negative 1. So what I would say is at this point, if there's a common factor that'll cancel, do that, stop right here.
Okay.
Okay? If you want to factor it further, what you could do is split it up If you have a negative 1, yes.
Yeah, so
Yeah.
still, I was just missing one part,
If you had made that a 6x to the -1, that would have worked.
okay.
Okay. Either way, you'll end up getting to there. Like we did
prefer
before.
if you split it, or if you leave it as one.
You can leave it like that. The only time I think they would want you to do that is like if they said show that the derivative equals this. But by the time you get down here, it'll be, you know, easy to get there. But yeah, once you factor out any kind of common factor that will reduce with the denominator, you can stop. Does that make sense?
Yes.
It is one more thing to memorize. This is in your formula booklet. Okay? I will say in your formula booklet, it is actually given, well, let's look at that. On your formula booklet right here. If I remember right, they use all the dy dx's, which is annoying, but you should be able to recognize. Go. Quotient rule, yeah. See, they use all the dy dx's and du dx's and all that thing. So, my thing is just memorize it, but if you forget, make sure that you've at least looked at these and you can figure out what it's saying. This is just v times du dx, so v times u prime, or u prime v, minus u times dv dx, that's the v prime, over v squared.
Why do they do that?
I think just to be consistent, but it is kind of a pain. That notation is helpful here on the chain rule, because you see the dy du times du dx, and then the du's are canceled and you have dy dx. So it's actually helpful to see that notation for chain rule. Product rule and quotient rule, though, it's just more of an
The
annoyance.
chain rule is where you find the derivative of the outside times the derivative of the inside, right?
Yes.
Okay.
Yeah. All right, let's try a couple of these, and then I'm gonna let you guys kind of practice together, or with a little more of this. Okay. So here, what's u on this first one?
1 plus 3x.
Good. There's our u. Always the numerator, which means that's v. U prime is
3,
3. V prime is
2x.
2x. Okay? So, u prime v minus uv prime all over v squared.
3x squared plus 1, right? Minus 1 plus 3x times 2x over x squared plus 1 squared.
There you go. X squared plus 1 squared. Don't bother foiling that out. Okay? Don't
Right.
ever bother foiling that out. So simplify the numerator as much as you can. 3x squared plus 3 minus 2x minus 6x squared. And then you get a negative 3x squared minus 2x plus 3 over the x squared plus 1 squared.
Why didn't you leave the x squared plus 1 in the numerator and just
You have to cancel it from there.
cancel it out?
You could, you'd have to split this into two separate fractions, and you'll still get kind of an ugly fraction over here. Keeping it all as one fraction will help us later when we want to find when this equals 0 and when it's undefined.
Okay. So
So-
it's just a judgment call based on whether you leave them in parentheses.
Yeah. In general here, all you're doing is distributing, so just distribute combined like terms to simplify your
Since
numerator.
there's no exponents, you mean?
Yeah,
You can just
there's nothing that'll factor and actually cancel, so if it'll cancel out something from the denominator without having to split it up, then go ahead and do that.
So like if it was multiplication, you'd be able to do that?
Oh, like here, if it were multiplication, yeah, you could cancel that with that,
And then it'd just be 3 times and you distribute.
yeah.
Okay. I think I need to take algebra again.
It's, and that's what can get frustrating. Sometimes you'll mess up, just make silly mistakes on the algebra that you know how to do it. It's just, it's easy to do that in the middle of one of these problems. Here's one where, again, this is u. What are we gonna have to do with v to when we do v prime?
Chain rule.
Chain rule. Okay. Chain rule. So what's our u prime?
Have x and negative.
Good. 1/2 x to negative 1/2. V prime.
It's 2 times 1 minus 2x times, what is it?
Times 4.
2, 4? No, it's just times 2, right?
No, I mean, like it's negative 4 times 1 minus 2.
Oh, yeah, because it's
But it's
times
times the two.
a negative 2. Because it's minus 2x there. So yeah, this would simplify. Because we're plugging it into the quotient rule, don't distribute. But you can go ahead and simplify this to a negative 4, 1 minus 2x. Remember, we don't distribute, because I told you, anytime we're dealing with the chain rule inside the quotient or product rule, we're going to be able to factor it out, so don't distribute here. Okay? So dy dx, u prime, 1/2 x to negative 1/2, times v, 1 minus 2x squared, minus u, oh, doesn't help us, x to the 1/2, times v prime, so a negative 4 times 1 minus 2x,
Now for this one, would it be better to just write in the denominator 1 minus 2x to the 4th, or leave it as 1 minus 2x to the 2nd, like squared? For factoring reasons.
You could just write it to the 4th.
To the 4th.
Yeah, because this whole thing is over that squared. So it is a 1 minus 2x to the 4th. Again, this is one of those cases that's really easy to forget to square it because it's already squared.
But in this case, you still can't take out a 1 minus 2x, right?
We
You
can
can.
because there's a 1 on both of them. This is why I said don't distribute this negative 4 in, because now we'll see it.
Okay.
We can,
This is where you split them, right?
you don't have to split it.
You can just take one from each.
Just take one from each, and that'll cancel out one of these.
Oh,
Okay?
as long as you're treating both sides equally.
So, let's see what we've got now that's left over. I'm going to distribute, this is a 1/2 x to the negative 1/2 when I multiply it by 1, and then minus 1 x to the positive 1/2, because it's a negative 1/2 plus 1, so it's positive 1/2. And then here it's a plus 4 x to the 1/2. That's canceled. This is all over 1 minus 2x cubed. I've got some like terms. Okay. I can write this as 1 over 2 root x plus 3 root x all all over 1 minus 2x cubed.
How far should we be simplifying it?
You could stop there.
Will we lose marks for not simplifying enough on the IB exam?
Most of the IB exam stuff is one of two things. Either it's pure application, so it doesn't matter how much or how little you simplify. Okay, all they care about is applying it to get your final answer. Okay, so we could leave it way up in that nasty stuff, not cancel anything out, as long as we're plugging stuff in right and getting the right answer at the end. It'll work. So you either have that, or they'll say, show that the derivative equals this. Usually in cases like this where a question of how far do I simplify is kind of ambiguous, they'll do one of those show us that it equals this. And then usually it'll follow up with some kind of application on like part B or C or whatever. And that way, what's nice about that too is if you do mess up something in the first part,
Then you can still gain.
you still have the right derivative that you can carry on to the next problem, next parts of that problem. That's something too, if you are running out of time for some reason, and a lot of times the application part, once you have the derivative, is pretty easy.
Mm-hmm.
So if you're running out of time, actually proving that it equals this is gonna take you a while, or maybe that's only like 3 points of it, and then the rest of it's 8 points. Skip that proof part, go do the application, and then come back if you have time.
That's why I
So-
asked, like, if it were, because you're running out of time, like, if you don't have to simplify all the way, then
Yeah,
why would you?
and that's the thing too. Okay, might you lose 1 mark or something if you don't simplify it all the way? Maybe, but if that gives you enough time to go on and earn 5 more marks on a different problem, it's a good trade-off. So that's just test take strategy, and that's why we're going to do some sample IB exams later in the year here. My goal is to be done with calculus, a good 6 weeks before your exam date.
When is your exam date?
It's May 12th and 13th or 14th and 15th. I forget. It's somewhere like in that second week of May.
What do we do after the exam?
Well, seniors are gone, and juniors,
Maybe like 3 of us.
Yes.
juniors, we will bide our time. You'll have other things you'll be working on. So,
Is that we don't have to come to the class, or? What is
no, you technically still have to come. It's just a matter of
Not seniors.
not seniors.
Not seniors, okay.
Because you're done with school, you'll have graduated already. by
Really?
the-
Oh, okay.
Um,
Cause isn't, I think I.
or no, you don't
no,
have to come after
26.
what, like
After your exam.
after your exam, you don't have to come.
Yeah, if you have an
Who's graduating?
external examination, as soon as you've taken the external examination, you're done with that specific class.
Cause I know that we graduate, I think, 26th.
Wait, it's your
Sure.
set
Yes.
for that one, should
And
we
the
do it
calendar
at
on the
negative 1/2?
You wanna go look it up.
For like, instead,
Here?
no, the top one, that one, so it's negative 1, it's x and negative 1/2. The next one.
No, because you had a negative 1/2 plus 1.
Oh,
So it ends up being a positive 1/2.
Alright.
So, yeah. Alright, I want to take some time here to practice some. And we'll get as much of this practice as we can in the last 25 minutes here. Or 20 minutes. And then we'll talk about what else we want to do near the end. Okay?
Alright.